In mathematics, we are taking R.D. Sharma solutions, class 12th, chapter 19, exercises 19.22 of indefinite integrals. Now, in this whole exercise, all of the question, they have trigonometry involved. So, if you know or remember the trigonometric identities or inequalities, equalities, everything related to trigonometrics, then it will be very easier for you to solve this. Most of the equations or identities we have been using a lot every time and now again and again. So what we are going to do here is we will try to make this integral in integrable form. If something is given directly, it is called as a formula. But if you can derive or make a question in a way or a problem in a way so that it becomes integrable or it becomes equivalent to a formula, we can directly write the answer. So we are dividing both numerator denominator by cos square x here. So when we are dividing cos square x, numerator denominator, we will be doing a lot in this exercise, dividing numerator denominator by cos square x. The numerator will become sec square x. This gets cancelled, so you have a 4 in the denominator. Then you have a 9. Sin square x by cos square x becomes tan square x. Now you see what you have to choose. Sometimes you don't choose it properly. Then you see that, oh, I have done a slight deviation from the actual track. For example, here if you see tan x, if you take tan x, you know that tan x will give rise to sec square x. So you need that numerator. So t equals to tan x dt by dx will become sec square x. That is dt will be equal to sec square x dx. Now you see the numerator of this expression which we have formed by ourselves by dividing numerator and denominator whole by cos square x. This sec square x dx is with us. And that has come when we put tan x equals to t, and incidentally tan x also has come from dividing by cos square x only. Now why this 9 is there? The examiner would have given you anything, but they know that you will do this tan square x, and then there will be something which we have to make a perfect square, and perfect square 9, that is 3 square is 9. So 3 tan x whole square x is 9 tan square x. And we know that a square into b square is a into b whole square. 9 into tan square x is 3 into tan x whole square. So this 4, 9, 36, wherever they are, you must pre-anticipate that it's going to be somewhere square. You have to take square somewhere. So 4 we have taken as 2 square. This 9 tan square x we have taken as 3 tan x whole square. Okay. So better is, since we have already taken this t now, so let's change this 9 tan square x as a 3t square. But still we are in a glitch because we have to, our whole way is to get to the solution where the integration is directly a result. That means integration of dx by a square plus x square we want, because we know the direct result of this thing. But 3t is still creating some trouble in that. So rather than writing this as 3t square, I will keep it as 9t square. And I will try to eliminate this 9 from t square. That is, just take this 9 outside. That means if you take some 9 outside, it is equivalent to dividing both numerator and numerator of the internal things by 9. So 9 we have taken outside. What is remaining? dt is already there. This is 2 by 3 whole square, because 2 square by 9, 2 by 3 whole square, that is 2 by 3 whole square is 4 by 9 only. That was initially there. Then we have this 9 and gets cancelled. So this dividing by 9 is just done because we want to get rid of anything which is accompanying t or x, so that we can actually use this formula integration of dx by a square plus x square. A is 2 by 3 and x is t here. So the direct result of this one is tan inverse x by a. There is 1 by a also. So 1 by 9 and this is dt. We have 2 by 3 whole square plus t square. Now this is a square plus x square, and we know the formula. Alright, 1 by 9, let me write it here. Tan inverse x by a is what? Tan inverse t by 2 by 3, 3 goes up, so 3t by 2. So tan inverse 3t by 2 you got. But 1 by a tan inverse x by a, the result of this dx by a square plus x square is 1 by a tan inverse x by a. I have written in the, when I was writing the formula, I forgot to tell you that it is 1 by a tan inverse x by a. So 1 by n is already there. 1 by a is what? So let me add this 1 by a first to complete this. 1 by a, which is 1 by 2 by 3, and tan inverse x by a, which is t divided by 2 by 3. So 3 goes up, 2 comes down. What this 1 by 9 into 1 by 2 by 3 will give you? This will give you 1 by 6. Tan inverse 3 tan x divided by 2 plus a constant of integration. So that's your integration, that's your final integration. And this is your final result also. So this is the result I was talking about. And whatever we have done, I have tried to explain all these things to you. Now again the same thing. Because the first question decides the building block or the pavement that you have to do mostly those things. So we are dividing here also 1 by cos square x. We are dividing everything by cos square x. So every term is divided by cos square x. The numerator will become sec square x. Denominator will become 4 tan square x. And plus 5 cos square x. Cos square x gets cancelled. So you have a 5. Now this is integration. In the previous question what we did? I told you that the sec square x will come from tan x. So just take t equals to tan x. Dt by dx will be what? Tan x will be sec square x. So dt will be equal to sec square x dx. So dx comes here, this one. So dt is equal to sec square x dx. So numerator you got, denominator also you got. This integration will become like this. Integration of, just write dt here, 4 tan square x plus 5. Now I told you that if we just take this as t, so it will be 4t square plus 5. No, you can write this 4t square always as 2t whole square. But that is not going to give a fruitful result in this particular question. Why? Because we'll write just like this, 4t square plus 5. Now, in order to get a proper result, that is the result that has been established, we need t square to be away from any coefficient. That is, we don't want 4. That is why we have taken 4 outside. And taking something outside means dividing it by any other term which is remaining inside. So 4 we have divided, 4 we have taken outside. So this 1 by 4 will come outside. And this is dt. And this 4 gets cancelled. So you have a t square. And then 5 by 4 we need to make it as a perfect square. For that we will write root 5 whole square, and 4 of course will be 2 square. So root 5 by 2 whole square. So this direct result we already know. Let me show it to you again. Integration of dx by a square plus x square or x square plus a square is 1 by a tan inverse x by a plus constant of integration. What is a here? A is root 5 by 2. And what is x here? It's t. So 1 by a, which is 1 by root 5 by 2. 1 by 4 is also there. So just multiply this one. Tan inverse x by a is what? X is what? T. And what was t? If you remember, t was already taken as 10x. So we will replace now. T was introduced by us. We don't need it anymore. We have come to a precise solution now. So tan inverse t was 10x. So tan inverse 10x. What is a? It's root 5 by 2. So 2 goes up. 2 tan x by root 5. Now let's resolve this. 2 goes up. 2 to the 4. So 1 by 2 under root 5. And this is tan inverse. This 2 goes up. 2 tan x divided by under root 5, and this is inside a bracket so that you show that it is tan inverse. This is the final result. Now how you are going to do this? All this has to be written, because knowing a question is something different and showing it that you know it is different. That's how you get the marks. Alright. Okay, 2 by 2 plus sine 2x. Now why this 2 is there? Once you open this sine 2x, because sine 2x can be directly by blind eyes, you can write 2 sine x cos x. Now whatever angle is there, the 2 sine x will always be half of that. That is 4x will become, sine 4x will become 2 sine 2x cos 2x, sine 8x will become 2 sine 4x cos 4x, like that. So this 2 has been added by the person who has made this question, because he already knew that this sine 2x will be expanded into 2 sin x cos x. So we will have all the 2's here. So 2 can be cancelled from numerator and denominator. So 2 here, 2 plus sin 2x can be written as 2 sin x cos x. Now you can take these 2 common from the denominator because you already have a 2 in the numerator, so that they can be cancelled. So when you take outside 2, 1 plus sin x cos x. 2 gets cancelled, 1 by, the integration will become like this, 1 by 1 plus sin x cos x. Now the next one will be what? We have a technique. What technique do we have? If you remember, because 2 questions we already done, we have a ninja technique. What is the ninja technique? Divide everything by cos square x and see what it gives us. So the numerator will become 1 by cos square x will be sec square x. Sec square x dx is also there. 1 by cos square x will be sec square x again. And here cos gets cancelled. Sin by cos will be tan. So plus 10x. So the integration will become like this. When you take this 10x, it will give you sec square x directly. But what we are going to do, what will we do with the sec square x in the denominator? We cannot replace it by anything. But we can replace it if we know the tan x and sec x relationship. Okay, this is a relationship, like you have a relationship with your father or a brother. Same way sec x has a relationship with tan x. Cosec x has a relationship with cot x. Alright, so we can write this as sec square x equals to 1 plus tan square x, that you already know in the previous classes, and you might have this in your heart, you might have learned by heart. So now this sec square x dx remains like this. Denominator sec square x, we are changing it as 1 plus tan square x. So 1 plus tan square x, and 1 tan x was already there. Let's write this tan x. So this t is equal to tan x. When you differentiate this, dt by dx is sec square x dx. So dt will be equals to sec square x dx. So we have the numerator now. This integration will become this sec square x dx is your dt. So this integration will become, numerator will be dt. The denominator will have 1 plus tan square x plus tan x. Wherever tan x is there, replace it by t. 1 plus t square plus t. Now what is our agenda? We need to bring the question in certain form which has a direct result in integration. This question is still not in that profile right now. So we have to change it. How are we going to change it? 1 plus t square plus t can be made as a perfect square. When you make it as a perfect square, that is t square plus t plus 1 in the form we are writing, because ascending to descending order of the power of t. So the coefficient of t is 1. We divide whatever is the coefficient by 2. Whatever comes, we square it and we add it and subtract it in the original equation. That is half square and minus half square. This we are adding and subtracting. Now you see, a square plus b square plus t, 2ab, t square plus half square plus t. What is this? T plus half whole square. And what is remaining? 1 minus 1 by 2 whole square. That is 1 minus 1 by 4. And this is going to be 4 minus 1 by 4. That is 3 by 4. And this becomes, if you have to make it as a perfect square, it will be root 3 by 2 whole square. Now let's bring it here in a written form now. dt by t plus half whole square plus root 3 by 2 whole square. Now the question arises is, how can you equate with the standard result? Because you will talk about dt by x square plus a square formula, just apply it here. But it's not x, it's x plus t, x plus half. That is, even if you take any of the letter in English, this t plus half is actually not equivalent to t or hex. So if you take it as u and differentiate both the sides, what do you get? You get du equals to dt. That's why we can take t plus half is equivalent to your x or t. That's why we can apply the formula directly. Otherwise, it would not be possible. So we have dx by x square plus a square. It has to be x, it has to be t, it has to be some variable. But since it is t plus half and we have already equated to u and showed it to u by taking u, that du by dt gives you du by dt when you take u equals to t plus half. So you have this 1 by a, which is 1 by root 3 by 2 tan inverse x by a, that is the direct result which we have seen in the previous questions also. So tan inverse t plus half by root 3 by 2. This 1 by root 3 by 2 goes up, root 3 comes down, tan inverse. Let's solve this first, t plus half. Now let's take the LCM now. So 2t plus 1 by 2 divided by root 3 by 2. 2 gets cancelled, you get 2t plus 1 by root 3. What is t? Remember, tan x was taken as t. Please remember, t was introduced by us. It is our responsibility to get rid of it also. So 2 tan x plus 1 divided by root 3, and this is plus constant of integration. That's your result, final result. Integration is this one. So this is the result which we talked about, and when I am explaining, I write so many things, but you have to write exactly or somewhat similar to this way so that you get the whole marks. Now cos x by cos 3x. Now let me be very frank in telling you the truth. I don't know the formula of cos 3x. I am writing this formula by seeing it. If you know it, I am saying I'm going down in front of you, because this is very difficult to remember all this formula because I don't have that neural circuit, so I can't remember it. But anyways, cos 3 theta is 4 cos cube theta minus 3 cos theta. Please remember it until you are in standard 12. So this cos x is in the numerator, cos 3x. You can write it as 4 cos cube theta minus 3 cos theta. And you see that cos theta or cos x is everywhere. You can just, I'm writing theta and x interchangeably, you know that, okay? It's all x, so just change this theta by x. Now take this cos theta outside. This cos and cos gets cancelled. What is remaining with us is 4 cos square theta or x minus 3. Now you can do this integration. Wherever theta is there, please remember it's x only. 1 by 4 cos cube theta minus 3. So just divide, ninja technique we have, divide numerator and denominator by cos square x. The numerator will become sec square x. Denominator will become this cos square get cancelled. 4 minus 3 cos square x. This goes again up 3 sec square x. Now this integration is like this, but we have numerator denominator same sec square x, so we can't do anything. So we have to convert the denominator sec square x in the form of tan x so that we can get the numerator by putting tan x equals to t, which we have already completed in the previous 3 questions and seen and understood also. So sec square x, we will write it as 1 plus tan square theta or x in the denominator only. See what games we are playing. Some people will argue, why are you not doing this in 1 plus in the numerator also? But it's our game. That's how mathematics works. So sec square x in the denominator we have taken as at tan square x, and sec square x in the numerator. But this 4 minus 3 into 1 plus tan square x will become 4 minus 3 into minus 3 tan square x. That will give you 4 minus 3 as 1 minus 3 tan square x. So now this to making it as a perfect square, you can write it as root 3 tan x whole square, because we need these in the denominator. So when we just place sec square x as 1 plus tan square x, we got what? Let me write it. I integration has become now sec square x was already there, 1 minus root 3 tan x, that what we got after applying sec square x as 1 plus tan square x. Now there are two things. See, a mistake I am committing right now, or you can say not a normal way. I am writing tan x equals to t. So dt by dx will be equals to sec square x dx, and we'll be very happy because numerator we have got. Alright? But there is a catch. I'll just show you what is the catch. Now this is dt by 1 plus root 3 tan x, or root 3, we have taken tan x as a t. So it will be root 3 tan t whole square. But the idea is that we want something so that it is directly integrable, or we have a direct result of integration. So there is a slight change I'll do. Root 3 tan x I will take as t. Not only tan x as t, but entire root 3 tan x as t. This will give you dt by root 3 as sec square x dx. Alright. So numerator will again be dt by root 3. So dt 1 by root 3 will also come here. And 1 minus root 3 tan x was taken as t. It was 1 minus this t square. So 1 square minus t square it is. So integration of dt dx by a square minus x square, you already know. So log a plus x by a minus x, you already know that. So 1 by root 3, 1 by 2 ln. It's not log, because log base e is ln only. Any other thing can be there, but ln is essentially log base e. So 1 by 2 ln modulus a plus x by a minus x. So 1 plus t divided by 1 minus t plus constant of integration. This gives you 1 by 2 root 3 and then ln. Now t was what? Root 3 tan x. Previously I took t as tan x. I showed you what was the problem. Then I took t as root 3 10x. So 1 plus root 3 10x divided by 1 minus root 3 10x and plus constant of integration. This is what we want. So this is the result which you are going to adopt when you are actually solving it. Alright. Now you can just make a portion somewhere in your writing that where you can show that what all formula you have done, what all calculations you have done. Now this question we are going to take in the next discussion. Till then, thank you so much. Have a good one. If you like it, you can just share it. Don't worry about liking, etc. All right. So this one more thing I will tell you that in a lower class 30-minute period is there. In a bigger class, engineering also medical 45-minute class is there, because people can only concentrate for a span. Okay, they cannot go beyond that number. So 20-minute video is good, I guess, but if you want to me to make it a bigger one or a smaller one, just let me know. Right.